Alright, this recording is for Module 6 practice test. If you have any questions, feel free to contact me. Alright, number 1 says find all the numbers for which each rational expression is undefined. If the rational expression is defined for all real numbers, so state. So what that means is that we never want the bottom to be 0. When it's 0, it's undefined. So if I look at the first one, I start looking at the x squared part and the positive part. No matter what I put in here, it's always going to be a positive number. There's no way I can ever cancel out this 25, because that's really what you want to do, is cancel out the 25. So for number 1, the answer is it's defined for all real numbers. So there's nothing I can do that'll ever make that bottom 0. I want to try to cancel out that 25, so I'm like, fine, I'll do negative 5 squared. But when I square a negative 5, it becomes a positive 25, and then it's no longer 0. So nothing we can put in there would ever cause that to happen. Number 2, because it's got that minus in there and a coefficient, it kind of changes things. So if I set this to 0 and I solve it, then I see that x squared would have to be 4 for this not to be true. So that means I can either have a 2 or a negative 2 as an answer. Either one of those will cause this whole thing to zero out. Okay. Number 3, simplify. So take care of your coefficients first. If I look at 16 and 12 and I'm just trying to reduce those, if I divide them both by 4, I get it down to 4/3. And then the rule for dividing is to subtract, so x squared, 2 take away 1 is just x. So our answer is 4x over 3, or you can also have 4/3 x. Either one of those will work. Alright, number 4. To simplify this, it looks like we're going to have to do some factoring. So let's factor the top. What multiplies together give you negative 18, adds together give you a positive 3. So I'm thinking 6 and 3 is going to work. And I need it to be negative, so that means one of these needs to be negative, but I want the middle to be positive, so there's the top. This is a perfect square, or sum of squares. So if you remember this rule, and then I can cancel out this and this, and I'm left with x over 3, x minus 6. So most of the time when it tells you to simplify, we're just trying to get it down to its simplest form. Alright, if you look at number 5, they are kind of opposites of each other. This is a negative 5, this is a positive 5, this is a positive x, this is a negative x. When this happens, if we factor out a negative 1 or a negative out of the top or bottom, let's do that. Let's take negative 1 out of the top. When I do that, I'm left with negative x plus 5, and then I have 5 minus x. So now our x's are both positive, and our 5's are both positive and our x's are both negative, so they cancel out and just leave our negative 1 as an answer. So number 6, we're just going to multiply or divide, add or subtract. So the rules on here is factor as much as you can, and then cross out wherever you can. So I factored that, that's not factorable. Alright, so if I look at these, we're good there. These x's cancel out, and then 3 goes into 12 4 times. So all we're left with is x minus 2 over 4. Number 7 is the same type of thing, but when you're dividing, remember to change it to multiply and flip. So I'm going to kind of factor as I write. And I'm going to put the x squared on top now, and then this is the difference of squares. And then I can, I can cross out, cross out, cross out, cross out, and I'm left with 8 on the top and x minus y on the bottom. Alright, number 8. Goal is, when you're adding, is to have the same denominator. So in this case we are. So that means everything on the top can be combined and then put over the same denominator. And we want to simplify. So 8 plus 4 is 12x. And minus 5 plus 1 is minus 4. Still over the same thing. I'm going to go ahead and factor this to see if it helps. So I can take a 4 out of there. If you factor and it doesn't help, then you didn't really need to factor. But in this case, when I did that, it came up with the same thing and we just left with a 4. So number 9, we need the same bottoms. So our LCD would be x plus 1 and x minus 3. So this term is missing the x minus 3, so that means I want to multiply this by x minus 3, and I want to multiply this with x plus 1. So our whole bottom will be this. Alright, so what I'm left with is the top, and I'm going to go ahead and FOIL this. X squared plus 5x minus 3x minus 15. And then we're going to minus the second one, which is x squared plus x. I'm going to go ahead and simplify it even further. X squared plus 5x minus 3x minus 15 minus x squared minus x. So I just distributed that negative sign. And then we're going to combine things that are good. This canceled out. 5x take away x is 4x. Oops, plus we have take away 3, so that leaves 1x. So that, and that are all taken care of. Take away 15, and then our denominator is still there. So we have x minus 15, x plus 1, and you can FOIL the bottom if you want to. Both answers will be correct. Alright, number 10. Do that on a separate sheet. 6x plus 1 plus 2 over x squared minus 1 plus 3x squared plus x minus 1. So first thing to do is find the LCD. If we factor this, that's what it looks like. So our LCD would be x minus 1, x plus 1. So that means that this guy doesn't need anything. Keep running off of there. And no students to tell me to push it up. Alright, our second one will be multiplied by x plus 1 because it's got the x minus 1 already. I'm going to go ahead and FOIL this. 3x 3 plus 3x squared plus x squared plus x, and then we're going to simplify it. Alright, so we have 6x plus x, which is 7x. We have no more numbers. We have 3x cubed, and then we have 4x squares. Now traditionally a math book will tell you to write it in descending order. I'm not going to mark you wrong if you don't, but just to make it look better, that would be the correct format. So the answer to number 10 is 3x3 plus 4x squared plus 7x plus 2 all over x minus 1, x plus 1. So don't forget your denominators. You do all that work, you don't want it to not get credit for it when you just did all that work. Alright, number 11 is a division problem, so that means we're going to flip and multiply and factor, factor, factor. So x squared minus y squared is a difference of squares. The bottom, it looks like we can take a 6 out of all. And then that looks like it can factor more, but I think I'm going to wait until I flip this. And then the top we can factor out this. We have x minus y, x plus y. And then we're going to factor out this guy more. Multiplies to give you 1, adds to give you 2. So 1 times 1. So 1 and 1, and they could both be negative to make this multiply to positive 1 and add to negative 2. So x minus y, x minus y, x plus y, 7x minus y. So we can cancel a bunch off here. So we got this with this. And looks like that's about it. So we have x plus y, and I'm just going to put squared. You could write it twice if you want to. And then 6 times 7 is 42, and then x minus y squared. Wow, that really bled through. Alright, number 12. Let's do it on a separate sheet of paper. So number 12 has fractions within a fraction, and you want to get rid of those. Makes it way too complex, and it's kind of like against the math rules. So what we want to do is we want to times everything by x. When we do that, you'll see that the bottoms will cancel out. So we have 5 times x, which is 5x. And then we have 5 over x times x, which is like x over 1. Well, these cancel out and just leave 5. The bottom, 2 times x is 2x. And then 1x times x just cancels out to 1. We could factor this, but it's not going to help because this one's not factorable. So number 12, this is our final answer. Right. Number 13 is the same kind of problem. We have a lot of fractions in the fraction, so we want to multiply everything by the LCD of all of them, which is x and y. So when I times 1x times xy, the x's cancel out and leave y. When I do 1y times x and y, the y's cancel out and leave the x. And then the bottom, 1x cancels out with the x and leaves the y. So this is your final answer. Alright, 14. So these all have the same type of situations in them. We handle them all the same. So it's finding the LCD of the fractions involved. So the LCD would be x squared. So everything's being multiplied by x squared. 3 times x squared. 12x times x squared. This x would cancel out and leave this x. So we're left with 12 times x, which is 12x. 1 times x squared is x squared. And then the x squares would cancel out and leave 16. Now this one looks suspiciously like you might be able to factor. So I'm going to go ahead and factor these out just to see if it's going to help anything. So if I divide the top by 3x, I'm left with x plus 4. The bottom is a difference of squares. And it did help us, so bam, bam. So we're left with 3x on the top and x minus 4 on the bottom. Alright, number 15. Solve each rational equation. So before we were just basically simplifying them because they didn't have an equal sign. All we could do was make them as simple. Now there is an equal sign, so there is a definite answer. Thing is, we do about the same thing as what we just finished doing. We find something that all the denominators would go into. In this case, it would be 6x. And then we simplify it as we go. So 3x times 6x, the x's would cancel out, and then we'd live with 18. 1 6 times 6x, the 6's would cancel out and leave the x. And then 1x times 6x, the x's would cancel out and leave the 6. And then we can solve this. I think I'm going to bring my x over here and my 6 over here. So number... sorry, this should be 12. So 18 minus 6. So my answer is 12. Number 16. Same thing, we got a fraction there. Multiply by what would get rid of that fraction. So x times x is x squared. 5 times x is 5x. 6 over x times x, x's cancel out and leave the 6. We're going to bring our 6 to the other side, and we're going to factor. So what multiplies to give you 6, adds to give you 5. So we have two options here. Only one will work. So we need it to be negative when we multiply, which means one of them has to be negative. So this one would not work because if one of these is negative, it will never add up to 5. So this is our winner. And then we want to set both of these to 0. So we get negative 6 as an answer and 1 as an answer. All right, number 17. So whenever we have a complex polynomial that's equal to another, we can cross multiply. So let's do that first. We have x minus 4 and x minus 1 is equal to 2 times 3x plus 8. So right now I'm just going to FOIL and distribute, get it into a more simpler state. Then we're going to combine like terms, put everything all on one side. And then put together things that are alike. And then we should be able to factor this. So what multiplies together give you negative 12, adds to give you negative 11. So obviously we're going to do 12 and 1. This would be negative, this would be positive. Set both to 0. So we can either get 12 or negative 1. Alright, number 18. So when there's more than one, we can't just cross multiply as we did before. So we need to find the LCD for all these terms. If I factor this, that's what I have, right? Because it's a difference of cubes, or a difference of squares, sorry. So our LCD would be this. Now you're multiplying everything by x minus 3 and x plus 3. So when you do that on your top one, the x minus 3's will cancel out and just leave your 2 and your x plus 3. Your second one, your x plus 3's will cancel out, and then you're left with 4 and x minus 3. Oops, that should be plus. And then our last term, we're going to multiply by this, so the bottom is going to completely cancel out, and we're just going to be left with 8. So now I don't want us to distribute and combine like terms all on one side. We'll just bring everything over this way. So minus, and this is -4, -4, and -6 is -10. And then we're going to set this to 0. So we get x is 5. All right, 19. 19 says solve each formula for the specified variable. And they want you to solve for q. So just like in our other questions, these are just like fractions. So we want to get rid of them fractions because we don't want our f on the or their q on the bottom. So we got to get rid of all the fractions. So if I times the LCD is PQF, that'll get rid of our fractions. So if I do 1p times PQF, the p's will cancel out and we're left with q and f. If I do 1q times PQF, the q's will cancel out and left PF. If I do 1f times PQF, the f's cancel out and I'm left with PQ. So we're trying to solve for q, and I see q in a couple places. So I'm going to put this q on this side. Now I can factor that q out, and I'm left with p minus f equals pf, because I didn't touch this side. I want q by itself, so I'm going to do p, they're multiplying, I divide, and then we're left with pf over p minus f. So number 20 is very similar. We're solving for p. So one way you can get rid of denominators is to multiply everything by the LCD. So we could times everything by p plus r. Or if it's one term equals one term, we can do that cross multiplying thing, and this is like a 1. So we have t times p plus r equals a times 1, which is a. Solving for p. I think I did not want to take it that direction. Well, yeah, let's do that. So I distributed, and I'm solving for p. I was forgetting what I was doing. I'm going to bring this over here, and then divide by t. So So you're going to manipulate your variables quite a bit, and sometimes it's not easy to figure out what to do. But you can remember two things when you're doing these. If they are in the denominator, we did the two examples that you could do. Find the LCD, times it, get rid of the denominators, because you never want your variable in the bottom. And in this case, we did our cross multiplication. All right, 21. Y varies directly as x and inversely as z. So if you remember that formula, that's our basic formula when we're talking inversely and directly and so on and so forth. So just remember, this is like your base, and then you build upon it depending on what they say. Alright, so they said directly as x, so this is a directly problem right here. This says y varies directly as x. That's what this says. But they added this thing on that says inversely as z. Well, inversely just means it's going in the denominator. Alright, so there's always two steps to these. The first step is that you're going to solve for k using whatever they give you. So you set it up, then you solve for k. So the very first thing they tell us is it's 126. Your x is 63. They'll never tell you what your k is, but they should tell you all your other variables. Alright, so if we multiply this by 16, that gets rid of that. 2016 equals 63k, and then we divide both by 63. And we get 32. Well, that's not the final answer. This just gives us our k so that we can do our second half of our problem using the same exact formula, but this time we know the k. So we're trying to find our y. This is our second step. But we know our x is 16 because they told us. We know our k is 32 because we found it in the previous problem. And we know our z is 4. So we get 512 over 4. And I get 128. So these are always two-steppers. Anytime you're varying directly or inversely, there's always two steps. You find your k first and then use your k value to solve. Alright, 22. In Stillwater, a paddle boat averages 20 miles per hour. It takes a boat the same amount of time to travel 72 miles downstream with the current as 48 miles upstream against the current. What is the rate of the water's current? So I always set up little charts. I put upstream and downstream. And we're trying to find the rate. So if you remembered, rate is distance divided by time. So I always write that here. And then this is my distance and this is my time. So they tell us that our distance was 48 upstream and 72 downstream. And then our time, they said it averages 20 miles an hour. Well, when you're going upstream, you have the current, and that's what X stands for, working against you. So you're going 20 miles an hour, but you got to take away the current that is pushing against you. Now when you're going downstream, the current actually helps you. So you're going 20 miles an hour and you get the current's push also. Now with this information, now we're just going to set the d over t. So our d is 48, our t is 20 minus x, and so on and so forth. And then the problem said it takes the same amount of time to do both of these. So that's where we set up our equation. So we set it up like that. So when you set this up, I'm cross multiplying. Oops, 1440 minus 72x. So if you do this, we end up with 120 x's on one side and 480 on the other, and we divide that out, we get 4. So it'd be 4 hours, or wait, not 4 hours, miles per hour. So the main thing to remember is, you know, setting these up. They give you, you know, how fast you're going in time, but you got to remember that the current works with you or against you. Alright, 23. A painter can paint a fence around a house in 6 hours. Working alone, the painter's apprentice can paint the same fence in 12 hours. How many hours would it take them to do the job if they work together? So we have a formula here where I can work a 1/6 of an hour working alone, and my friend can work a 1/12 of an hour working alone. So this whole thing equals 1. It's 1 whole hour. So whatever this is a partial of an hour, and this is partial hour, but it always equals an hour. So a 1/6 and a 1/12. Now I have that fraction that I want to get rid of, so I'm going to times everything by 12. This leaves with 2x, and this leaves with 1x, and then don't forget also you multiply your last one by 12. Combine like terms, and I get 4, so if we work together we can do it in 4 hours. (24) Use similar triangles, and in fact the corresponding sides are proportional to find the length of the side marked with x. Alright, so the main thing on here is just to make sure you're matching up the correct sides with the correct sides. So we have the angle here, and we have a right triangle here, so we know that this side and this side match. We know this side and this side match, and we know this side and this side match. So we can set a proportion up and be able to solve for unknown side. So if we do 30 meters, and we're going to match that with the 10 meters, and we can equal, and we need to know what this x is. Now since I put the big triangle first, I want the big triangle first here. So we cross multiply. 180 equals 30x, so x will equal 6, so 6 meters. Right, 25. The amount of current flowing in an electrical circuit varies inversely as the resistance in the circuit. When the resistance in a particular circuit is 5 ohms, the circuit is 42 amperes. That's amps. What is the current when the resistance is 4 ohms? So you know you're going to have something that looks like, oops, I wrote that wrong, this. Because remember the standard formula is this, but as soon as they say inversely, then something got to go down, and it's always going to be the x. So our first step is to plug stuff in and solve for k. Alright, so, and our x in this case is our resistance, so that we can keep track when we're reading. And then y is our current. Alright, so using this formula, they tell us that the resistance is 5, so that means 5 is going down here, and they tell us the current is 42. We can cross multiply if you want. 42 times 5 is 210. K times 1 is k. So our k value is 210. Now using the same formula that we used in the first part, we're going to plug in our k, and then we're going to read what it says. So it's what is the current, so we're trying to find our y when the resistance is 4. And remember, resistance was x, and we had that at the bottom. So 210 divided by 4 is 52.5 amps. Alright, if you have any questions, let me know.